Hi students, welcome back. Let's continue with our display devices in the computer graphics. So in the previous video I explained about CRT and the random scan. Now let's see the raster scan display. In the random scan, electron beam uses just like a pencil and it draws the line segments. So it just draws the line segments. Then how the display technique that will be occurred, the image that will be appeared on the screen by using the raster scan display. Let's see. In a raster scan system, the electron beam is swept across the screen, one row at a time from top to bottom. So here the technique it follows is one row at a time from top to bottom. So whereas in this random scan, the image, the electron beam first directs to wherever it wants to point out, only to that portion where the image has to be displayed. In that portion, the electron beams will be generated. So here the raster scan, it takes the electron beam is swept across the screen one row at a time from starts at the top and ends at the bottom, top to bottom. As the electron beam moves across each row, the beam intensity is turned on and off to create a pattern of illuminated spots. Okay, so here what it is doing, the electron beam is moving across each row. So I said this is so whatever the picture that I have shown you in this random scan. So here also let's take these are the lines, okay, scanning lines. So here the electron beam moves across each row. So first starts here and ends here, after that again starts here and ends here, like this. Okay, so electron beam moves across each row. The beam intensity is turned on and off to create a pattern. Let me explain you. Suppose this is the screen. So here I want to draw E. Okay, letter E on the screen. So the electron beam starts in each row. So starts, let us take this is like this. The screen is like this. This is scanning lines. So here at this position the electron beam is turned on, and up to here it is turned on, and all this the electron beam is off. So again it comes back. So this position electron beam is off. Again it on in this position, and after that it is off. So like that, wherever you want the picture, there the electron beam intensity is turned on. So the remaining part of the screen, the electron beam is turned off. So but the electron beams has to move across each row. So it has to move across each row. So wherever the image has to be displayed, in that position the electron beam is turned on. Okay. So picture definition is stored in memory areas called the refresh buffers or frame buffer. So here the picture definition, whatever the picture that you want to be displayed, that is stored in the memory area called refresh buffer or frame buffer, you can call it. This memory area holds a set of intensity values for all the screen points, and its stored intensity values are then retrieved from the refresh buffer and painted on the screen one row, that is a scan line at a time. So it just that refresh buffer, whatever the retrieved from the refresh buffer, that value that is painted, that is printed on the screen one row, that is a one scan line. This is scan line, one row you call it as scan line, and this is another scan line. So each row you call it as a scan line. Okay, and this you call it as a horizontal lines. So these are the horizontal lines, and when you going back, this is a vertical retrace. This is a horizontal retrace and this is the vertical retrace. So the electron beam starts here and continue till the end of the screen. Again it comes back to the next row and continue till end of the scan line, and again comes back to the starting of the third row and scan line, and continues until the scan line ends. Okay, suppose if I want to draw here B. So the electron beam starts here at this position, the electron beam is intensity is off, and here it is again on. Okay, and up until here it is on, again it is off here, the electron beam intensity. Even though it is scanning the complete line, wherever the image wants to be printed, in that place only the electron beam is on. The remaining places it will be off. Okay, again it coming back, here it is on, it is coming back. Okay, coming back, it is on, back. So in this position it is off, again here it is on, in this off, on, off, like that. Okay, so here each screen point is referred as a pixel. So each screen point, this you call it as a pixel. At end of each line, the electron beam returns to the line. So here at each position, the electron beams is going to returns to the left side of the screen to begin display the next scan line. Now let's see the types of scanning or traveling of a beam in raster scan. So how the type of scanning will be occurred or traveling of a beam in raster scan is it? There are two ways. That is, one is interlaced scanning and non-interlaced scanning. The type of scanning can be done in raster scan like using interlaced scanning or non-interlaced scanning. Now let's see the interlaced scanning. Interlaced scanning here, each horizontal line. So horizontal line means, so this is a scan lines. You are coming back. This is a horizontal line. Okay. So here each horizontal line of the screen is traced from top to bottom, due to which the fading of a display of object may occur. So this problem can be solved by non-interlaced scanning. So in this, first of all, odd numbers lines are traced or visited by an electron beam. Then in the next circle, even number of the lines are located. So first it locates the odd number. The electron beams has to be visited, odd numbers has to be visited by the electron beams. Later it will visit the even lines. So that is the interlaced scan. And non-interlaced scanning, here the display refresh rate of 30 frames per second is used, but it gives flickers. So for interlaced display, refresh rate of 60 frames per second is used. In non-interlaced, only the 30 frames per second is used. If you use the 30 frames per second, it flickers. So in the interlaced displaying, we are using the refresh rate is 60 frames per second to overcome that disadvantage. Now let's see what are the advantages and disadvantages of using the raster scan. The advantages are, it's a realistic image, million different colors to be generated in the raster scan, shadow scenes are possible. Whereas the disadvantages are low resolution when compared to the random scan, and it is very expensive when compared to the random scan. Thank you.